All right, let's jump right in. We're going to tackle a piece of the mainframe that is absolutely critical, but, not a lot of people really get it. I'm talking about the ZOS system logger. Now, the best way to think about it, it's the system's indestructible black box. And by the time we're done here, you're going to see exactly why that matters so much. So here's our game plan. We'll start with the big idea of the black box, then get into the architecture, see how records move around, and even look at how you define a log stream. Then we'll get into some pro tips for CICS and wrap it all up with some best practices for beginners. Sound good? Let's get to it. All right, Section 1, the system's black box. So what is the ZOS logger, and why should you even care? Well, think of it as the silent guardian, the unsung hero of data integrity on the mainframe. It's the thing working away in the background, making absolutely sure that nothing, and I mean nothing, ever gets lost. So let's just think about this for a second. In a world where mainframes are chugging through millions upon millions of transactions, what happens when things go sideways? I'm talking a full-on system crash, maybe a power failure. How in the world does the mainframe remember every single event? How does it keep from losing even one tiny piece of data? The answer? Well, it's pretty elegant, actually. It uses its indestructible black box, the ZOS system logger. And that black box analogy, it's not just for show. It is perfect. Its entire job is to reliably record absolutely everything, no matter what chaos is happening around it. So here's the key takeaway. The system logger is a centralized service. What does that mean? It means applications like CICS or IMS don't have to worry about building their own complicated logging systems. Nope, they just hand off their log records to the logger. It does all the heavy lifting, capturing the data, storing it safely, and even merging logs from apps running on totally different systems in a Sysplex. It's like having a universal scribe for the entire environment. Okay, so we know what it is. Now let's get into the fun stuff, how it's actually put together. We're about to break down the core components of the logger architecture. This diagram here gives us a fantastic bird's eye view. You can see the applications on the left, writing their data into this central log stream, which then gets safely tucked away on permanent disk storage. But the real magic is in the details, right? So let's pull this whole thing apart, piece by piece. Okay, first up, the most fundamental piece of the puzzle, the log stream. Just think of it as a continuous, dedicated log file, like a single massive ledger that just keeps growing. Applications write to it one after another, sequentially. And hey, if you've ever touched CISCs, you've already seen these in the wild. I'm talking about DFH log and DFH shunt. Next up, we have the coupling facility, or CF for short. Now, this thing is special. It's a piece of hardware that's all about speed. It's basically a chunk of super fast shared memory that every system in the Sysplex can get to in a flash. For the logger, this is the perfect waiting room, a temporary holding spot for log data. Why? Because writing to the CF is way faster than writing to a disk. And when we're talking performance, that's everything. But remember, the CF is just a temporary stop. For the permanent, long-term home, that log data gets moved to what we call offload data sets, which live on good old-fashioned disk, or DASD. And what if the coupling facility itself has a bad day? Well, that's where staging data sets come in. They're an optional safety net, a real-time backup on disk of whatever's in the CF. Pretty smart, right? All right, we've met the players. Now we can talk about the two main ways a log stream can actually be set up. This isn't just theory. It's a fundamental choice a systems programmer has to make when they build this stuff. And this table breaks it down perfectly. You basically have two paths you can go down. Path A is the coupling facility log stream. You use this for that super fast shared access across your whole Sysplex. This is your go-to when you've got apps on different systems and you need to merge all their logs together. Then there's Path B, the DASD-only log stream. It's simpler. If your log is only ever going to be used by one single system, this is the way to go. It just uses local buffers instead of the big shared CF. So how does the data actually make the journey from that speedy temporary storage to its forever home on disk? Well, it's a slick, automated process called offloading. Imagine the CF is like a bucket. As log data pours in, the bucket starts to fill up. When it hits a certain point, a high water mark that you define called high offload, that's the trigger. The system logger wakes up and starts bailing out the oldest data, moving it to the permanent offload datasets. And it keeps bailing until the water level drops to a low water mark, which you guessed it, is called low offload. That frees up space in the bucket for new data to pour in. Okay, we've talked a lot of theory. let's get our hands dirty. How does a systems programmer actually go about creating one of these things? So the master control file for all of this is something called the logger couple dataset. You can just think of it as the rulebook or the logger policy for the whole Sysplex. And the tool you use to edit this rulebook and define your log streams is a handy utility called IXMIPU. Now, I know looking at a wall of JCL can be a little intimidating at first, but trust me, the important parameters are really simple. First, you give it a unique name. Easy enough. If you're using the coupling facility, you tell it which structure to use with struct name. You use dast only to say, yep, this is a dast only one. Then you see our old friends high offload and low offload to set up that automatic bailing process we just talked about. And finally, LS size and STG size are just where you set the size for your permanent and staging datasets. See, when you break it down, it's not so bad at all. Okay, let's zoom in a bit and talk about some really practical pro-level tips. We're going to focus specifically on tuning CICS log streams, things like DFH log and DFH shunt, because let's face it, these are often the busiest and most critical logs you'll deal with. Getting these right is a huge deal.
All right, first up, high offload. For those super busy CICS logs, you want to set this somewhere between 80 and 85%. And here's why. These logs can get hammered with data. Setting it this high gives the offload process a crucial head start. It gives it enough breathing room to start clearing out old data before the log fills to the brim and brings your CICS region to a grinding halt. It's all about avoiding those waits.
Now for the other side of that coin, low offload. Here, the sweet spot is somewhere between 40 and 60%. This is all about finding the right balance. You want to keep enough of the most recent log data handy in that fast storage, just in case you need it for a quick transaction backout. But you also want to clear out enough space so the offload process isn't kicking off every 5 seconds. 40 to 60% is that happy medium. Okay, here's one of those super specific technical nuggets that can make a massive difference. For your offload datasets, the control interval size, or CI size, should be 24 kilobytes. Just 24 KB. This isn't a guess, it's a proven best practice that directly optimizes the I/O performance when the logger is writing that data out to disk. It's a small change with a big impact. This quote from IBM is fantastic because it highlights how things have changed. See, there's this CISCS parameter called the log defer interval, LGDFINT. The original idea was to wait a tiny bit and bundle log records together to save on I/O. But as IBM points out, given the speed of more recent processors, it is better to send the log blocks more frequently. Basically, our CPUs are so ridiculously fast now that waiting just creates an artificial bottleneck. A high value here can actually slow down your transactions. So the rule today? Keep it low. We're talking 5 milliseconds or even less. Wow, okay, we have covered a ton of ground. So let's bring it all home and wrap up with the most important best practices. Think of this as the essential checklist that every beginner should have pinned to their wall. All right, here's your cheat sheet. Rule number 1, and this is a big one, never mix your DFH LOG and DFH shunt streams in the same CF structure. They just behave too differently. On that note, try to group other log streams that have similar activity levels together. It just makes things run smoother. Next, an obvious but crucial one, keep your production and test systems in separate structures. That's just good system hygiene. When you're sizing your offload datasets, go big. The default is tiny and will get you in trouble. And please use SMF type 88 records. They are your secret weapon for monitoring performance and figuring out if your sizes are right. And finally, for CICS logs, make sure you're specifying offload recall no. So let's end with this. Getting your head around the ZOS system logger, it isn't just about learning some tech specs. It's about understanding the fundamental engine that guarantees data integrity on the mainframe. It's the system's memory. It's that indestructible black box. So the question I'll leave you with is this. Now that you know how it all works, what critical data are you going to be trusted to protect? Thanks so much for joining me.